Some time ago I posted a video on this. It's a power supply based on the Riden RD6012 switching controller. So the 6006 is this front part, it's just a switching controller, and the rest of it is back-end power supply. This particular unit has a switching supply for back-end. I did go on to make a linear back-end version of this supply, and I posted some videos on that. And it was quite popular. It's been quite a useful supply. I wouldn't use it as a primary lab supply. There are certain features I didn't particularly like, which I pointed out at the time. But also it is a switching supply, and it will always be inherently noisier than a linear supply. They're not meant to compete with true linear supplies, but having said that, it is a very nice supply and it has been very useful. So I bought a number of these, and as I say, I also made a linear version. And really the reason I got this is I wanted a high power lab supply, and it's 360 watt output, so 6 amps at 60 volts, so quite capable. But they have brought out a unit with twice the power. So for anyone that's interested, I thought what I would do is put that unit together. So I have bought all the parts required. So this is the RD6012. So this is 60 volt, 12 amps. So twice the current output of this unit, same voltage, but twice the amount of current. So what I've bought is the actual controller itself, a switching supply, and as previously I also bought the enclosure kit. I paid just on £100 for everything delivered. It's taken about 2 months to arrive. I ordered it from a Chinese import company. Now, I won't say who I bought it off. You can shop around and get these from many places. And the reason I don't say where I buy things, I have been asked on a number of occasions to specify where I bought particular items from. And the reason I don't normally do that is because I do tend to get a lot of issues and problems buying off eBay and online. So I don't want to be painted with or tarred with the same brush if you have the same problem. For example, there's one clown that leaves thumbs down on every one of my videos because he bought something off a website that had nothing to do with me. For some reason he seems to think that it's something to do with me, so he demanded a refund off me. And of course, because he bought nothing from me, I refused to refund him anything. So that's why I steer clear of trying to end up being blamed for things that I have no control over and have nothing to do with me. But if you shop around, you can find these. I actually found there was a kit listed on the same site that was all these 3 items together, but actually cost I think £20 more for the 3 items as a kit than it was to buy them separate, so it is worth checking the prices. But as I say, these 3 items together came to just under £100 delivered. It's taken just over 8 weeks to arrive. So what I thought I'd do in this video is put this together, and in the next couple of videos then I'll run it through its paces and see if it's any good. It won't be an exhaustive review, but it will just be running through and try and give you some idea as to whether these are worth purchasing or not. Now, in the RD6006 videos that I posted, I went through the assembly process, got a few critical responses saying that you didn't want to see me putting screws in and assembling these things. If that's the case, that's fine, just ignore the rest of this video. If it's not your sort of thing, that's okay, but that's what I'm going to be doing in this video. So spoiler alert, if you don't like seeing things assembled, this video is not for you. So what I'll do is get this unpacked, and we'll see what's in the boxes that I bought, and then we'll go and start assembling it. So as I said, I bought the case kit as I did on the 6006 version. You can buy all these items separate. They are kind of standard items to a certain extent, although the the RD versions do have the correct parts in the kit, so that you can pretty much just bolt it all together. So this is just the enclosure, almost identical to the enclosure that I bought previously. And it comes with hopefully all the parts I need to assemble this. So we've got the metal chassis, top clamshell cover. I'll just quickly look in the bag and make sure we've got everything that we need. Okay, so what's in here? Lots of plastic bags. So interconnect cable kit, switches, socket, and the hardware and mounting kit. So that's all you need to actually assemble this unit, and as I say, I'll be bolting this together. You can put this together any order you want, it doesn't really matter. You can fit the sockets and the cables first, or the transformer and the controller. It doesn't really matter, there's plenty of space inside the enclosure to be able to work around whatever order you decide to assemble in. So we'll get that out of the way for now. I also bought a switching power supply. Okay, now one of the things that comes with this particular supply, if you run these without any particular load on the outpost, then you'll get a lot of RF noise, especially the thing runs at very high frequency with very short on times. So what you can do is fit a load resistor, which they do actually supply in this kit, so that's quite nice. I doubt I will be using that. There's sufficient load on it with the controller that this shouldn't be needed, but I'll check that once it's all assembled. Okay, and then we have the RD6012 unit. So I'll just pop this open. And as you can see, it looks pretty much identical to the 6006. It even looks very similar inside. The basic layout is very similar, same sort of design, which is not a bad thing. The 6006 works fine, so hopefully this will as well. It is noticeably heavier than the 6006. Now, I did buy the Wi-Fi module with this, so hopefully I'll be able to give that a test and see if it works. There are some sort of dubious specifications for this, and the instructions do make it fairly clear this may or may not work, so we will try that. Not very well packaged, of course. Just putting it in a polythene bag like that is not a particularly good way to package these, but we'll see if that works later on. And then we have the terminal connections, and that's pretty much it, and a spare fuse. Okay, now as with the previous units that I built, I'm going to remove the outer cover from the switching supply. I'm also going to take the fan out and put the fan on the rear case of the enclosure that I bought. Now, I did have some people commenting on that on the previous build, and just to clarify, this is not really a force-cooled unit as such. It's not, the fan's not blown across a specifically designed heatsink. All it's trying to do is get air into this cabinet and blow air through it. So with this out of the way, this doesn't really serve any purpose. It doesn't really add much to the screening either, from the perspective of noise. We do have the outer enclosure. It might make a minor bit of difference, but in all honesty, the difference is so small it's not really worth considering. The nature of the noise is such that this doesn't make that much difference. If you're worried about it, then of course you can leave the fan as it is and fit an extra fan to the outer case, but I prefer to have just a single fan running, and to have this open within the outer enclosure just helps with the cooling. So I'm just going to pop this cover off, and then we'll have a look inside the switching supply as well, and then we can start the assembly. Okay, so we have the case separated, and the next thing is to figure out how we're going to get all this assembled. So firstly I'll check to see how long the cables are, and that'll give us some idea as to what possibilities we have. This doesn't look to be as comprehensive a kit as was supplied previously. There were much better DC leads on the previous kit. I do still have those. I didn't use them on the linear version I built. I might swap those out. But one thing to note is that if we want to mount this using the cables that come with this, we need to mount it with the screw connector towards the front, otherwise the DC cables won't be long enough. So we should be able to get those cables attached first. We'll connect the live and neutral, so they're the connections on the left hand side. Okay, and this one is the ground. And as with all kits like this, we'll just give them a bit of a tug to make sure they've been properly crimped. They're fine. And while we're here, we'll also attach the DC cables as well. And because this is a 12 amp supply, there are dual cables, so we'll fit them all now. And again, just check that they're all crimped properly, and that's fine. So the next thing is to offer this up to the case. Now, if you did watch my series on the RD6006, you know I had an issue when I put it together that the mounting screws actually were too long and they cut right through and hit the connections on the bottom of this PCB. So we'll check that when we assemble it all. Now I believe in this version they actually supply shorter screws. They're a lot shorter than they were in the previous version, so I don't think we'll have the same problem, but I will check that anyway. I'll get this bolted in and I'll get back on camera and then go from there. Okay, so I've checked and they've used the correct length screws this time. They're not long enough to go all the way in through and short anything out, so that's a bit of an improvement in the kit. I believe they've changed that since the original kits. And what I'll do now is fit the feet to the case. Okay, so that's the feet on the case. Next is the supply itself. So it doesn't make any difference here whether you fit the supply first or the actual switch and the connector. I'm going to fit the supply first this time, and all I need to do is figure out which of the particular holes I need to line up to get this screw to the base. Okay, so I've had a look at this and it's quite a nice layout they've got here, that when the supply is in the correct location, the original fan mounting is adjacent to the fan outlet on the case. I don't particularly like that arrangement. It'll cut down the airflow, but it does mean that the single fan arrangement will work a lot better than on the original design. But what I'm going to do to make this work a little bit better is I'm going to remove this rear flange from the switching supply, and then I can bolt the fan directly to the outer case, and that'll give me much better airflow through the entire unit. So I'll just go out to the workshop, quickly cut this off, and then we'll get back and continue with the assembly. Okay, so I've cut the rear flange off the switching supply, and that will now enable me to bolt this in and still be able to bolt the fan to the rear case of the supply. So I've now got plenty of space, and of course it will give me the proper airflow through the entire enclosure. It does also mean at this point, if I wanted to, I could refit the outer cover of the switching supply, and that would tend to cause air to flow through this part of the supply itself, but I'm not going to do that. It's quite a narrow enclosure anyway, and as I said, if I do get any heat issues, then I will try refitting this, but I suspect that this layout, especially because of the location of this lower vent, will give us a very good airflow through the switching supply. So I'll now get this bolted in place, and then we can look at getting the fan fitted and the mains components clipped into the rear panel and screwed in place. Okay, so I have the power supply bolted into the enclosure. That fits in extremely nicely. Screws are exactly the right length, and the whole thing is now a nice robust assembly. So what I can do now is bolt the fan to the rear cover of the enclosure, and then plug this back in, and it will give us effectively the same kind of physical layout for the cooling that the supply on its own had. And of course, because we're drawing air in at the front, it's being soaked through the entire length of the supply. So I'll get this bolted in, and then we can move on to wiring up the mains connections. So that's the fan bolted into place and plugged back in. I used the same mounting screws that it came with, and quite a nice layout. It all fits together nicely so far. And the next thing is to fit the mains power switch and the mains socket. If you've assembled one of these before, you'll notice they've actually moved the location of these two components, so this is quite nice. And also there's some mounting here for the temperature control board, which is no longer supplied. It wasn't in the kit this time, so there is no way to control the temperature of the fan other than using the switch mode supply, but that will work fine. This particular supply has a controlled fan anyway, so it's not needed with this particular layout. So next thing, we'll get these components popped in. So this main socket just pops through the holes, a couple of screws supplied, a couple of nuts, and then the switch just clips into the hole at the top. So I'll get those fitted, and then we'll look at getting the wires connected. Okay, that's those components fitted, went in place very nicely. One thing I would comment with on this is, having now assembled quite a few of these, it's clear this company is actually developing these. They haven't just made something low cost and then just sold the exact same one indefinitely. They are thinking this through, they are modifying it, developing it, improving it, and that is very evident. Having put this particular one together, everything fits much better than on the previous ones. By the time I'd got this far on all the previous ones, it used to rock about, and the holes weren't in quite the right place. They seem to have dealt with that. All the parts fit much better. I don't know if it's going to work any better, but it certainly goes together a lot more nicely than the previous versions. So next thing we need to do is get the mains wiring sorted out. So we'll start off with the earth lead. Okay, so that's wired up. I'll get this cable tied and tidied up, and then we can fit the Riden controller. Okay, that's the wiring tidied up. One minor comment I'd make here is, it is nitpicking, but it's something that is worth considering when you're building things like this, is when you make an assembly like this and you're supplying cables or you're wiring up the mains cabling, it's better to make the ground cable, the earth cable, slightly longer than the power cables. That's the live and the neutral cable, so they should have kind of a loop in the earth here. And the reason for that is, if for any reason this gets pulled or knocked or moved and the cables start getting pulled out, the last one to be pulled out should be the earth. The way they have this arranged, if you were to pull this, the first one to come out would be the ground cable, which is obviously not what you want. That should be the last one to detach. So an extra inch of cable, 2 inches of cable on the ground here would be ideal. As I say, it's nitpicking, but it is something that's worth considering if you're building one like this from scratch and you're cutting the cables to length. Okay, so we're now ready to fit the Riden controller itself. I will be adjusting the voltage on this supply, but I want to get the controller in place first, and we'll adjust it under load. I'm not fitting the ballast resistor at this point. We'll see if we need it. If we do need to fit this, I will fit it, but we'll have to have a look and see if we're getting any noise at very low power output. Okay, so we can now fit the Riden controller itself. It is nice that they have changed the graphic on the front as well, so it says 6012. I was expecting it to still say 6006, but they have dealt with that. As I say, they do seem to be actually developing this quite nicely, so we'll see how it goes. One thing I have noticed is that there's a socket here next to the what seems to be the main fuse that doesn't have a fuse in it. Now there is a spare fuse that comes with the kit, so I'm wondering if maybe the socket is just to enable you to fit a fuse if you blow the one that's in there. So what I'm going to do is, just before I go any further, measure across this and see if the socket is wide across the existing fuse. And we'll see if these are wide together. So all I'm trying to do here is see if this fuse socket, I don't know how clear you can see this, is wide across the existing fuse. So that end is indeed, and so is that. So yes, the fuse holder, the socket, is wide across the existing fuse. So if you do have a problem, there is a spare fuse that comes with the kit, but presumably you can just plug that into the socket. So someone was really thinking here. That's a really good idea. And we've got the same thing, I assume, over here with the second part of the controller. So someone's really put some thought into the design of this, and it does make it much easier to support this sort of product when you don't have to start unsoldering surface mount fuses, and especially with power supplies like this that can get a bit of a hard time. It's nice that someone's gone to the time and effort and cost of putting a socket in there in addition to the existing fuse. Okay, so as I said, with this particular kit I did get the Wi-Fi module, so we can plug that in now. As I say, it does say instructions say it may or may not work, so we'll plug it in anyway, and I'll test that in a future video. Okay, so we're now ready to bolt it all together. So what we can do is take the plug off here, and there is a silkscreen legend in there that shows us which way around to connect it, and there are obviously 4 connections, 4 wires. So let's get those put in, and then we can test the actual supply and see if it's working. Okay, I've got the power socket fitted. I've double checked to make sure I've got it wide the way that's shown on the silkscreen legend. But before I plug it into the controller, I'm just going to power this up, make sure the switching supply works the way it should, and we'll measure across the output, and we should be getting about 70 volts. So firstly, we'll power up the bench supply, and then we'll power on the switching supply. Oh, no smoke, and nice low current. It's drawing about 0.05 amps from the mains at the moment. So we'll bring in the multimeter and see if we're getting the right voltage. So right on 70 volts, so that seems to be working just fine. Okay, so what I can do now is attach the Riden and see if it powers up correctly. Okay, and then we'll plug that into the enclosure. Just clips into place, and we're ready for a first power up. Let's remove the front screen guard so you can see it a bit better. Okay, now we can switch it on. Okay, so it's come to life. What I need to do now is plug in the temperature sensor, and I'll attach that to whichever of the two heat sinks proves to be getting hottest under load. So I'll do that next, and then hopefully we should get some temperatures indicated on the display. Okay, I've got the temperature sensor fitted, so we'll do a final check before we put the outer cover on. I've tidied up the rest of the wiring as well, and we'll just see if we're getting temperature reading, and if we are, I'll refit the outer cover. And we are indeed now getting temperature showing on the front. This sensor is actually intended for battery charging, but I'll never use this unit to charge batteries, so, oh, not directly anyway. So I'll use the temperature sensor to monitor the internal system. So what I'll do now is put the outer cover on and have a quick look at it to make sure it's all behaving the way it should. And then in the next video I will do some more thorough testing. Okay, so that's the unit assembled. Quite a nice looking unit, and went together very nicely. Actually went together a lot better than the 6006. So we'll power it up one last time for this video. And just do a quick voltage test to make sure we're getting something out of it. Another modification I will be making with this, as I've done on the other units I've built, is because I'll never use these for charging batteries, I will be changing this terminal function to earth ground. At the moment it's green, but it's not ground, it's the battery charge output, which is kind of a bit strange, but I'd never use it for that, so I'd changed the internal wiring, disconnect it direct. I disconnect it from the charge function, of course, and then I disconnect it direct to chassis ground, earth ground on the unit. Okay, so we're getting 70 volts going in. It's set to 5 volts out. We'll turn it on and see what happens. So just under 5 volts. Try changing it. $10 volts. It's working. 20. And right up to 60 volts, so that's working fine. I won't go any further in this video. This was just to show me putting it together, but in the next videos I'll try testing it, running it up to its full power output, making sure it survives, and then we'll see if we can get the Wi-Fi working and connecting it to the software. Any comments welcome. Any particular tests you want me to carry out, then please let me know. And I'll also be reviewing the firmware in this particular unit to see if it's the same as on the 6006 in terms of the way that the voltage limits, current limits, etc. work, and in particular the memory functions.